This video is on the objective solve trigonometric equations with multiple angles. And this is the second video on this objective, so hopefully you've watched the first one. These are equations where you have a single trig function, sure, but the angle inside the trig function, the argument of the trig function, is not just theta or just x or just beta, but it's 2 theta or 3 theta or 4 theta or half theta, right? Something else. Some multiple of theta or multiple of x or multiple of beta, alpha, whatever. Now you're still going to solve these, again, as you saw in the first video, in a very similar fashion to the way you solved linear trigonometric equations with one function. Now I personally like doing it with a substitution, as you'll see in a minute. Alright, so again, if you want to see more about it, this objective, when you're on this, when you see a question with this objective, click on more instruction, look at their videos, their notes, their examples, and hopefully those help. Alright, so we're asked which of the following are solutions, so select all that apply, to this equation. We have 2 times, now it's another cosine one, right? I know the first video had a cosine as well. Just pay attention, it might be a tangent, a sine, a secant, a cosecant, whatever, right? A cotangent. So, I'm not going to go over, this will be the last video on this. I'm not going to go over every possible scenario you can come across. All right? I'm just hoping that these first 2 are reasonable guides for you. And I'm hoping you can fill in the blanks and do your own thing if you see a different kind of function later. So I have 2 times the cosine of, see, it's 3 theta, right, instead of just theta. And this is equal to negative square root of 2. And they're looking for, now they're not looking for all the solutions, right? They're just looking for the solutions, the values I can replace theta with that are between 0 and 2 pi. Let me write this equation out. So we have 2 times the cosine of 3 theta. When is that equal to negative square root of 2? So like I said, this is a linear equation in cosine. You see, you have a cosine function to the first power, and that's it. So treat it like one, right? Just like every other linear equation in one of the trig functions, you get that trig function alone. So the first thing I would do here is divide by 2. So we have the cosine of 3 theta is equal to negative square root of 2 divided by 2. Right. Now the trig function is alone. And here's where it gets a little different, right? I want to have this be like our original linear function, the linear equations. When there was just theta or just alpha or just beta. Just a single letter in here and not a multiple of it. 3 times theta or 2 times theta. So what I'm going to do, and you saw me do this in the first video as well, I'm going to make a substitution. Alright, so I'm going to substitute for this 3 theta just a single letter. Just a letter that I haven't seen yet. Maybe alpha. Why not? Or x or y or z, something else. So now we're looking at this. After I make that substitution, this equation now looks like this. It's the cosine of alpha equals negative square root of 2 divided by 2. And what I'm going to do here is find the general solution to this equation in alpha, and then we're going to substitute back and solve for theta. So let's find the general solution to this equation with alpha first. Alright, so remember how I solved these, these linear equations once I isolated the trig function. And you just think around the unit circle once, think about going around the unit circle once counterclockwise. And what angles had a cosine of negative square root of 2 over 2. Well, those would be 135 degrees or 3 pi over 4 radians. So alpha, this substitution variable, alpha could be replaced with 3 pi over 4, but also plus any multiple of 2 pi. Remember, if I add 2 pi, subtract 2 pi, I'm back to the same spot, so I have the same cosine. So 3 pi over 4, alpha could be replaced by 3 pi over 4 plus 2 pi times k, where k is an integer. But that's not the only angle, right? That's not 3 pi over 4 is not the only angle that had a cosine of negative root 2 over 2 when you went around the unit circle once counterclockwise. The other one would have been 5 pi over 4, right? That would also have a cosine of negative square root of 2 over 2. So alpha, this substitution variable here, could also be replaced with 5 pi over 4 plus any multiple of 2 pi. All right, so again, 2 pi k, where k is some integer. All right, so what I've done here is I've solved for this alpha. Right? I've described all the solutions to this equation in alpha. The original equation, though, had the variable theta. We're trying to find values of theta that make the original statement true. So now that I've solved for the substitution variable, I'm going to substitute back and solve for theta. So I'm going to sub back. All right, so everywhere there's an alpha, right, replace it with 3 theta. So instead of alpha being 3 pi over 4 plus some multiple of 2 pi, we have 3 theta can be 3 pi over 4 plus some multiple of 2 pi, right? 2 pi k, where k is an integer. Or, again, alpha here, just go back to 3 theta. 3 theta could be 5 pi over 4 plus 2 pi k, right? Plus some multiple of 2 pi. And then I take these new equations and I solve them for theta. And we'll get the general solution of the original equation in theta. Now to do this, it's very simple here. You just multiply both sides by 1/3. Right, that would make that theta on the left. Now you gotta be careful, there are 2 terms over on the other side, so we're going to distribute the 1/3. Same thing for this line. Right, I would multiply both sides by 1/3 to solve for theta, and do the same on this other side. But again, there are 2 terms over here, so I need to distribute the 1/3, multiply every term by 1/3. And then we finally get the general solution of the original equation, right? The equation with the variable theta, let's say of original. So from the first line, theta could be replaced with 1/3 of 3 pi over 4 is just pi over 4. Plus, and then 1/3 of 2 pi k would just be 2 pi over 3 times k. Right. So this means that theta could be replaced with pi over 4 plus any multiple of 2 pi over 3. Or the other line, multiplying this by 1/3, theta could be equal to 1/3 times 5 pi over 4 would be 5 pi over 12 plus, and then 1/3 of 2 pi k would be 2 pi over 3 times k. So again, another more solutions we could get for this equation is 5 pi over 12 plus any multiple of 2 pi over 3. So I'll put this in a box. This is a description of all the infinitely many solutions to our original equation in theta. Right. But I don't want all the solutions, right? They just want certain ones, right? Values of theta that are between 0 and 2 pi, including 0 but not including pi. All right, so what I'm going to do is, as you've seen me do in past videos, I'm going to list some solutions coming from this. So we have theta can be equal to, now if k is 0, then you just have pi over 4 and 5 pi over 12. These are some solutions to this equation. And I'll add some more here. Now as I go to the right, I'm just going to, every time I increase k by 1, we're going to be adding 2 pi over 3 according to these lines. Now 2 pi over 3 is the same as 8 pi over 12. I'm just trying to get a common denominator here. And then going this direction, I will subtract 2 pi over 3 each time, or subtract 8 pi over 12. And we'll list a bunch of solutions to this equation. Now, pi over 4. If I get a common denominator, pi over 4, that's the same as 3 pi over 12. Right? And then I'm just going to keep adding and subtracting 8 pi over 12. So 11 pi over 12 would be another solution. Right? And then adding another 2 pi over 3, adding another 8 pi over 12. That would be 19 pi over 12. That would be another solution. Adding another one, 27 pi over 12. Well, this would simplify to 9 pi over 4. Right? 9 pi over 4, 27 pi over 12, same thing. But still, like I just keep adding. This is telling me up here to take these two solutions, keep adding and subtracting 2 pi over 3. And then going this way, subtracting 2 pi over 3, get negative 5 pi over 12, and so on, right? They're not accepting negative solutions, right? They want solutions from 0 to 2 pi. So let's say, yeah, you can keep going if you want. All right, then 5 pi over 12, do the same thing. I just keep adding 2 pi over 3. Well, if I add 8 pi over 12, that'd be 13 pi over 12. Add it again, you get 21 pi over 12, which would reduce to 7 pi over 4. Right? And add one more, you'd have 29 pi over 12, and so on. And subtracting 2 pi over 3 would give me negative pi over 4, right? Negative 3 pi over 12, but this is negative pi over 4, and those are negatives and they're not going to be counted. But what I've just shown you here are 10 solutions to this equation, 10 of the infinitely many. But they don't want 10, right? They don't want all of these. We just want the solutions to this equation that are between 0, right, the values of theta from 0 to 2 pi, right, including 0 but not including 2 pi. Now 2 pi is 24 pi over 12, right, if you write it with a denominator of 12 like the others. So which of these solutions I've mentioned fit the bill? Let's see, pi over 4 works and is also in this range. Another solution I'm seeing in this range is the 5 pi over 12. 11 pi over 12 is in here. 19 pi over 12 isn't bigger than 2 pi. That's in here. Now 9 pi over 4 is too big, right? The rest of these are too big. 13 pi over 12 is okay. 21 pi over 12 is okay. But then 29 pi over 12 is too big, and they're too big the rest of the way out when I keep adding 2 pi over 3. There, so those 6, pi over 4, 5 pi over 12, 11 pi over 12, 13 pi over 12, 19 pi over 12, and well, I'm sure it'll show up as 7 pi over 4, right? These are the same. And let's go back and check those off. So again, I had pi over 4. Oh, come on. Well, there are 6 of them, but I guess the only ones that show up here, let's see, was 7 pi over 12 on my list? No. 11 pi over 12 was on my list. 13 pi over 12 was on my list. And so was 7 pi over 4. They're missing 5 pi over 12 and 19 pi over 12, but I'm sure that they just couldn't, they don't put in don't put in more than 6 choices. But there were 6 solutions that fit this description. We only had to select these 4 though. Right. Yeah, see they got 5 pi over 12, they've got 11 pi over 12, pi over 4, 5 pi over 12, 11 pi over 12, 19 pi over 12, 13 pi over 12, and 7 pi over 4. See, they got 6 of them here. They describe them, but only those 4 were on the list. Okay. So again, hopefully seeing me do this 2 times, one time when the argument was 2 theta, this time the argument of the trig function was 3 theta. Hopefully watching me do this a couple times helps you out, whether or not it's 2 theta, 3 theta, 4 theta, half theta, quarter theta, third theta, might be stuff like that inside your trig functions for other problems like this. Again, I'm only doing these 2. I'm not going to go over every possible scenario you could come across because then I'd be making way too many videos. But I'm hoping watching these 2 is a good enough guide for you for when you see other problems related to this objective. And again, hopefully, hopefully watching me do these and looking at the more instruction and reading the answer explanations when they come up. Hopefully all that stuff helps you out when you're doing these problems, working on this material on your own. And thanks for watching.